Hi, my name is Shruti Kedarnath, and I'm going to be doing the honors problem on skip lists and binary search trees. So let's look at what happened here. So first, since the key is 10, we compared it from negative infinity and 20, which is the next one, and 10 is less than 20, so we moved to the second row. And then on the second row, again, we compared it, 10 is less than 20, so we moved again to the third row, and again, 10 was less than 20, so they inserted this key to the left of 20. And then this is where the coin flips came in. The first coin flip was true, it was heads. And this is why we added a 10 on top in the second row, and then the second coin flip was tails, which was false, so we did not add another 10 on top of that. So now let's look at the binary search tree. So basically 10 is less than 20, so it was added to the left of 20 in the binary search tree. So let's look at what happened here. We had the key, which was 20, and this is how it worked out. So first, we saw that 20 is less than 40, so we went to the second row. And then here, we saw that 20 was not, it was greater than 10, but again, less than 40, so it went right in between those two. And then we went down another step, and we saw that again, 20 was less than 40, but greater than 10, so we added it over here. And then this is where the coin flip came in. The coin flip that we used for this one was 1, 0, which meant that the first one was heads, which means that we added a 20. And the second one was, so we added a 20 on top of this 20. And then the second one was tails, which was 0. So that meant that we did not add anything on top of that one. Now give me 1 second to pull up technical difficulties. Okay, perfect. So we added another 20 on top. We added the 20 on top for the first one, which was a 1, which was a heads. And then we added nothing on top for the second one because it was a 0, which was tails, which meant that's where it stopped. Now let's look at the binary tree. So what happened here? So we went to the 10, and we know that 20 is greater than 10, so we went to the right. And here we saw 40, 20 is less than 40, so therefore it was, we went to the left. And again, we saw 20 here, which is the same value, so we added it to the right over here. So let's look at what happened there. We are trying to delete 5. So what the program did was first it looked at the first one. 5 is less than 30, so we went to the second row. 5 is again less than 30, so we went to the third row. 5 is again less than 30, so we went to the fourth row. And now 5 was less than 10, so we went to the next row. And again, 5 was less than 10, and here was, so we went to before that actually, let me clarify. For the fourth row, we had the 5 that was right in between the negative infinity and the 10, so we went to that position. And then we followed it down, and we saw that there was another 5. And so therefore, we isolated the 2 5s that were in our skip list, and we deleted those from the bottom up. Now let's look at how it works when we're deleting 5s from a binary search tree. So this one was, we looked at the 10, and we looked at, since 5 is less than 10, we went to the left, and then we saw that the 5 was there, and it removed the 5 from the tree. So what happened here? We are looking up 80. So we're trying to find 80 in our skip list. So first we look at negative infinity, 30. We know that 80 is greater than 30, so but less than positive infinity, so we go down. We also know that, again, 80 is greater than 30, but less than positive infinity, which is the important part. It's less than positive infinity, so we go down again. And now we know we have the 40 here, and we know that 80 is greater than 40, but less than positive infinity, so we go to the 40 position, and then we move down again. Again, 80 is less than positive infinity, but greater than 40, so we move down again. And now we move to the right. We know that 80 is greater than 50, so we move to the right again, and we see here that we found our 80 using those methods. So now let's look it up in our binary search tree. So what happened here? We have 10, which is the beginning of our tree, and we know that 80 is greater than that, so we went to the right. And this arrow, now we have 40, and we know that 80 is also greater than 40, so we went to the right again, and here we go. We found 80. Thank you so much for listening.